Hi everybody. This is a lesson. It's probably going to take two parts to talk about the surface areas of prisms, cylinders, and then the second part is going to be of pyramids and cones. All right, so here's a lot of vocabulary. You are welcome to pause this and write any of it down that you're not familiar with. A prism is really a polyhedron that has two congruent faces that we call bases, and those are parallel. So in this case, you can see here's my base. It's a rectangular base, and here's my base. And they're parallel to each other. The other faces, the non-base faces, are called lateral faces. So 1, 2, 3, 4. There's 4 lateral faces. And they're just parallelograms that are formed by connecting the corresponding vertices of the bases. So this vertice, all these vertices, there's one. All these vertices, there's another. And the segments that connect these vertices are called lateral edges. So right here, this is a lateral edge. Right here, this is a lateral edge. Well, in between those lateral edges are the lateral faces. All right, so if we're trying to find the surface area of a prism, one thing you have to know about is altitude or height of a prism, and it's really the perpendicular distance between its bases. Now, in a right prism, which is mostly what we will be finding surface area of, each lateral edge is perpendicular to both bases. So the height is the slant height. It's the same because this would look like this if it were a right prism. But prisms that have lateral edges that are not perpendicular to the bases are called oblique prisms. So you can see this is a lateral edge and it's not perpendicular to the base. So that is called an oblique prism, and oblique lateral edges really is the slant height of that prism. Okay, and the other thing to remember, and I talk to my Math 7 honors kids about this all the time, they seem to struggle with it. Prisms are classified by the shape of their bases. It's all about the bases. So if I have a prism where it's got a triangle on top and a triangle on bottom and then a bunch of rectangular lateral faces, that is still a triangular prism. The surface area of any polyhedron is the sum of the area of all its faces. Okay, so the lateral area of a polyhedron is the sum of the area of just the lateral faces and not the bases. So we're going to get more into that. Let me show you what I mean. Okay, so if we had to find the surface area of this prism, and this is a rectangular prism because the bases are both rectangles. And if we're trying to find the surface area of this right rectangular prism, we know its height is 8, and its length is 3, and its width is 5. How would we do that? Now, I know you guys are going to want to launch right into a formula, but what I want you to think about first is what this thing would actually look like if you deconstructed it. Think of it as a cereal box that you cut up to lie flat. And what you would notice when you did that is that you would have two sides that were 3 by 5. And you would have two sides that were 3 by 8. Two faces that were 3 by 8 from your box. And then you'd have two more faces that were these sides here of the box. So they were 5 by 8. So if we're trying to really look at what the surface area is no more than adding up the area of all of the faces of this polyhedron. So this is 15 and 15 and 24 and 24 and 40 and 40. That's all it is. And if I add all that up, I get 158 inches squared as the surface area of this rectangular prism. And that really, what I was doing was a net. It was imagining that I cut up the edges and tried to lay it flat. So if you looked at this shape here, which is a right hexagonal prism, and you were able to cut it up and unfold it, you would see that here would be each of these sides, right? And then the bases here would look like that. And this two-dimensional representation of all of these faces is called a net. And its nets are just important so that you conceptually understand what it is we're doing when we're calculating surface area. So an interesting thing to look at in this net is that, yeah, I could see that if I'm trying to find the surface area, I'd have to find the surface area of these two hexagons of my bases. But then I also need to find this surface area. And what would this surface area be? Well, if you look at it, this corresponds to that corresponds to that, this comes here, that comes there, and that comes there. So this length here is really just the perimeter of what my base was, in this case a hexagon. But this length just represents the perimeter of that hexagon. This is the height of my polyhedron, of my prism in this case, because it is the distance between the two bases. So all I would do to find the area of this part would just be to multiply the perimeter by the height. So that leads us to really what the formula is, which is what you probably will most frequently use instead of drawing all this out, to find the surface area of a prism. The lateral area is just the perimeter of the base times the height that we just discovered in that last slide. And then the surface area is just your lateral area plus 2 of your bases. And the big B in this case represents the area of the base. So you need 2 of those because each prism has 2 bases. So if we are now going to find this surface area using our formula, what would we do? Well, we know that the surface area is going to be equal to the lateral area plus 2 times the area of the base. In this case, my base is a triangle. This is a triangular prism. I also know that the lateral area is just the perimeter of that triangle times the height, the distance from triangle to triangle, from base to base, plus 2 base. So the lateral area is easy to find here. The perimeter of this triangle is 3 times 7, or 21. My height is 5, so I've got the 21 times 5 part. Now I need to find the area of the base, and I hope we all remember that with an equilateral triangle, the area is radical 3 over 4 times the side squared. So in this case, we're going to be adding radical 3 over 4 times 7 squared, but we need 2 of them because I have 2 of them, this one and that one. So when I simplify that, I get 105 as that part, right, plus if I did 2 times 49, 4, in this case I could go ahead and give a simplified radical. That would be, let's see, 49 squared. But it's going to get really messy, so I can just do the calculation in my calculator for this, and it will approximately give me 147.43 meters squared for the surface area of this triangular prism. Okay, what if I'm trying to find the surface area of this hexagonal prism? All right, so once again, my surface area is just equal to my lateral area plus 2 of my bases. And we know my lateral area is the perimeter times the height, and 2 of those hexagonal bases. Okay, so in this case, once again, the lateral area is easy for me to calculate. The lateral area is just going to be the perimeter, which is 6 times 6, or 36, times the height, which in this case is 12. So that is going to give me the area, the lateral area, which really ends up being 432. So now the tricky part of these bases, but it shouldn't be so tricky to us. We know that this is a regular hexagon, which means that each of those angles there is 120. If I blow this up to try to figure out what my apothem is, you know that this is 6, this up here, well, this one's 90, this would be 60, and this would now be 30. And the half this distance would be 3. So if this is 3, please excuse my dog. Daisy, be quiet. If this is 3, then this would be 6, and the apothem would be 3 rad 3. So now to find the area of the base, it's 1/2 times the apothem times the perimeter of the hexagon. So that'd be 1/2 times 3 rad 3 times the perimeter, which in this case is 36. And that simplifies to 54 rad 3. So I put this all together, and my surface area is going to be equal to, depending on how I want to, if I want to be precise, it would be 432 plus 54 rad 3. If I want to get an approximate answer and see what that is, it's approximately 619 meters squared. All right. So now if we're looking at finding the area of a cylinder, surface area of a cylinder, it's just a solid with congruent circular bases. So it's a prism as well. Another word for a cylinder is a circular prism because it has parallel bases that are circles, and it has a height, which is the distance between those bases. But in the case of a circle, we also have a radius. And a right cylinder is just telling us that the segment joining the centers of the bases is perpendicular to the base. So whatever this line would be perpendicular to this base. Okay, so the lateral, this is kind of interesting to think about. If you have kind of a piece of paper and you wrapped it into a circle, it's easy, and then you put a top and bottom on it to make a cylinder. It's easy to see that the bases, the area of the bases are just pi r squared. But what would the area, this lateral area would be? Well, it's just kind of opening this up and stretching it out, right? And if we open it up and stretch it out, this distance here is just the circumference of the circle, or 2 pi r. This distance here is the height, h. Therefore, the lateral area of this is 2 pi r h. So this once again brings us to our formula. And our formula, once again, it's really not any different. It's the lateral area plus 2 times the base, once again. But in this case, our lateral area is 2 pi r h, and in this case, our bases are 2 of those circles, or 2 pi r squared. So if we're going to find the surface area of this right cylinder, it's pretty easy. Our lateral, we're just looking for 2 pi r h plus 2 pi r squared. So it's 2 times pi times 3 times 4 plus 2 times pi times 9, right? 3 squared. You put that all together and you get 42. Oh, this needed to be a plus. Doesn't look like a plus. 42 pi feet squared, which would be the precise answer. If you wanted to approximate it, it would be 131.95 feet squared. Okay, and if we're looking at surface area of pyramids, a pyramid is really a polyhedron in which the base, this one, I think we're going to stop here because it's going to go too long. So basically, what we've done in this first lesson is figured out surface area for prisms. And those prisms are shapes in which the bases are the same shape and they're parallel. And so we talked about triangular prisms, we talked about square prisms, rectangular prisms, and this cylinder, which is really just a circular prism. Okay, so now the next lesson is going to be on pyramids and cones.